Hey geometry friends, welcome to section 2.6, which is all about planning a proof, which is actually kind of what we've already been doing, but as we're approaching the last section here of chapter 2, we're just adding more repertoire. We're adding more weapons that we can use as reasons for our proofs. So this video is just going to give you a couple more theorems that you can use as reasons in your proofs, and then in a separate video, I'll go through a couple of proofs with you and give them a try and see how you do. So go to this diagram over here, folks. Can you see that angles 1 and 2 here are a linear pair because, well, they're a pair and they add up to a straight line. And 3 and 4 over here are also a linear pair. Remember, we learned by the linear pair postulate that if you're a linear pair, then you are supplementary. So 1 and 2 are supplementary and 3 and 4 are supplementary. Okay, great. But let me add one little wrinkle to it. What if I told you also that I knew that angle 1 was congruent to angle 4? They have the same measures. So again, 1 and 2 are supplementary. 3 and 4 are supplementary, which means they both add to 180. But angle 1 is congruent to angle 4. What can you say about angle 2 in comparison to angle 3? Would you believe that they are actually also congruent, but not to 1 and 4, but to each other? So we could say that angle 2 is congruent to angle 3. Now let's see. Let's see why. Okay, let's say, for example, that angle 1 was 100 degrees, and if I say that angle 4 is also 100 degrees, because they're congruent, can you figure out what 2 and 3 are? We know that 1 and 2 are supplementary, so therefore if 1 is 100, then 2 must be 180 minus 100 is 80. Okay, same thing over at the 3 and 4. If 4 is 100, and those are supplementary, then angle 3 must be 180 minus 100 is also 80. Hey, did you see? So angle 2 and angle 3 are the same. So look how we set it up. Ready? This becomes a new theorem, and this theorem has a title. So when you use this theorem in a proof as a reason, you can just refer to it by the title. You don't have to write out all the words. But here you go, folks. This is great, again, for flashcards to help you remember writing this one down. Look what it says. It says, if two angles are supplements of congruent angles. So meaning, if, like we said, if angle 2 and angle 3 are supplements of two congruent angles, that's what that says. So if angle 2 and angle 3 are both supplements or supplementary to two angles that are congruent to each other, 1 is congruent to 4, or possibly if they're supplementary to the same angle, then you guys could say that angle 2 and angle 3 are congruent. Then those two angles are congruent. So because 2 and 3 are supplements to two congruent angles, then 2 and 3 have to be congruent themselves. It just makes sense. And here we proved it kind of with just some numbers. So we showed that 80 is congruent to 80, so 2 is congruent to 3. Okay, that's the congruent supplements theorem. If two angles are supplements of two congruent angles or of the same angle, then those two angles are congruent. Okay, now a lot of times for a theorem, it's really helpful if we can actually prove it down here, prove that it's true, and then we can use it in a proof later on if we want. So let's actually go ahead and try to prove this theorem. Why does this theorem work? Let's check it out. All right, here is how we're going to set up our two-column proof here, folks. Ready? So 2 columns here. Left column is always the statements, and the right column is always the reasons. Okay, here's your given. This whole group right here, this is entirely given to you. So that is set in stone. Your job, friends, is to prove that 1 is congruent to 3. Okay, let's read the given. The given says angle 1 and angle 2 are supplementary, and they look like it. They look like they add to 180. And then angle 3 and angle 4 are also supplementary. Again, that looks true. And then they gave us one extra thing that I'm going to make sure I mark in my diagram. Angle 2 is congruent to angle 4. And again, it's really good to always mark your diagrams because it helps you see what we're trying to prove. We're trying to prove now that angle 1 is congruent to angle 3. Okay, that's our proving here. Now, you might think, well, why don't we just use the congruent supplements theorem? Didn't we just learn that, Mr. Brown? And you're right, but what we're doing is we're proving the theorem. We can't use the theorem when we prove the theorem. It's kind of like saying we're going to prove that the sky is blue by saying it's blue. So you have to prove that it's true, and you can't use it as an actual reason. All right, so here we go, guys. First step in every proof, remember, the given. So why don't we go and just copy down all the given here. We can say that angle 1 and angle 2 are supplementary. I don't have a lot of space, so I'll just initialize it, abbreviate. I'll say that angle 3, angle 4, also supplementary. And I'll say that angle 2, I'm running out of space, sorry, is congruent to angle 4. Okay, that's all statement number 1. Why? What's the reason usually in every first step of a proof? Given. Yay, it was given to us. So we're going to write that down. Okay, now a lot of times we want to try to build an equation or somehow use the given to write more statements and get to the proof. So another good tip for proof writing is squeeze the juice out of the given. I'm going to write that down because it sounds so weird, doesn't it? Squeeze the juice, meaning take everything you know from the given and try to write something based on that. So I wrote the given, and that's great, but what does it mean to be supplementary? Can we use that somehow for step 2? If 1 and 2 are supplementary, what does that mean? Well, it means that they add up to 180, right? So let's put that down. That's step 2. So I'm going to say the measure of angle 1 plus the measure of angle 2 add up to 180. Why? Because they're supplementary, right? Well, if it happens because they're supplementary, then we can just say by the definition. If it just seems like, well, duh, it's because they're supplementary, then usually the reason is a definition. By the definition of supplementariness, they add to 180. So not only do postulates and theorems help us out, but definitions, basic definitions, help us out as reasons. But could we also say that, over here, let's squeeze some more juice out. 3 and 4 are supplementary, right? So can we use that as a step in the proof? Sure. Let's say that in the same step. How about the measure of angle 3 plus the measure of angle 4 equals 180? Same reason, right? So I can put it in the same step. So step 2 has 2 things in it. Angle 1 plus angle 2 equals 180. And angle 3 and angle 4 equals 180. Why? Because they're supplementary. So by the definition of supplementary. Okay, that's a great start so far. But now look, let's use some of our equations. Well, we both know that they equal 180, right? 1 plus 2 is 180. And 3 plus 4 is 180. So what can you say about the two left-hand sides here? If they both equal the same thing, can you see that they are also equal to each other? So can we say, step 3, how about the measure of angle 1 plus the measure of angle 2? Since that's equal to 180, well, so is 3 plus 4. So why don't we set them equal to each other? So I'm going to say the measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus the measure of angle 4. Why? Because they both equal 180. Now, what did I do, though? To get from 2 to 3, what did I do? You see how they both equaled 180? So it's like I took the 180 here, which is equal to 3 plus 4, and I subbed him into the game. Oh, I said the word substitute. It's substitution. By the substitution property. Because it equaled 180, I could sub 3 plus 4 in for the 180 in the other equation. Okay, this is looking good. Now I'm a little stuck. Okay, and whenever we get stuck, just go back to what we're trying to prove. What are we trying to show here? We need to show that 1 is equal to 3. Now go back to where we are here in step 3. I need 1 to equal 3. Look how close we are. 1 is almost equal to 3 if I could just somehow get rid of 2 and 4. And the only way to do that is maybe to subtract them away. But I can only subtract 2 and 4 away if I know they're congruent. Do I know if they're congruent to each other? Yes, we do. We said that in the given, right? We know that 2 is equal to 4. So therefore, if I take them away, I'm taking them away from both sides, and that's legal. I could say that by sort of mentally crossing them out. I could say in step 4 that the measure of angle 1 is equal to the measure of angle 3. Why? Well, we basically just took away angle 2 and angle 4. We subtracted them. Ah, it's the subtraction property. Yay, we did it. We did it. Now, we really should show that 1 is congruent to 3. So, I mean, this is sort of a parentheses step that you don't necessarily have to do, but it would be nice to end on exactly what we're supposed to prove. We're supposed to prove that 1 is congruent to 3. And, I mean, for a reason for that, we can just say the definition of congruence, that because they have equal measures, then they are congruent to each other. But honestly, we do not really use this step too much. You'd be okay to put this step here on step 4 and put them together. You can say that 1 is equal to 3, and therefore 1 is congruent to 3 in the same step. So could this be a 4-step proof? Absolutely. Oh, so look what we did. We proved a theorem. Something they said must be true, and we just proved it. Look how good you are. But again, another great tip is squeezing the juice out of the givens. Use everything you can out of the givens to put some statements down. Whether you know if they're going to be right or not right, you don't necessarily know, but just give it a try. All right, what other weapons could we use? Do you guys believe that if there's a congruent supplements theorem, that there's going to be a congruent complements theorem? And there is. So another weapon, write this one down, put a flashcard for it. If two angles are complements of congruent angles, or the same angle, then those two angles have to also be congruent. And again, same reasons as we had on the front page. I could show you a diagram of some angles that are complements, and they would eventually be congruent. So since they are complementary, meaning they add up to 90, to two congruent angles, then those angles themselves also have to be congruent. Okay? We don't have to prove this one because the way we prove it is very similar to what we just did on the previous page. So I would just say believe it, write it down, and memorize this beautiful one. Then we'd go through a couple of really good practice proof using both the congruent supplements and the congruent complements theorem, but I'm going to save that for another video for you if you want to try them out. But let me give you one more amazing weapon, another reason. It's a very easy one, but it's a very cool one. Right here, your last theorem of the section and your last theorem of the chapter. It's called the right angle congruence. Do you believe, friends, that if I have a right angle here, which means he's equal to 90 degrees, and I have another right angle over here, which means he is equal to 90 degrees, do you believe that those two angles are congruent? Well, yeah. Why? Because they have the same measure. So every right angle is congruent to every other right angle. Basically, this says that all right angles are congruent. Again, a very short, a very simple theorem, and it just makes sense. So we don't have to prove this one because it is a very basic one, but again, another great one to use in proofs. That if you ever need to show it, that every right angle is congruent to every other right angle. So this is called the right angle congruence. It's got a title. So when we use it in a proof as a reason, we can just use the title, that all right angles are congruent. All right, friends, that's the end of section 2.6. In another video, I'll go through these 1, 2, 3 proofs here in case you want to give them a try. But what I would suggest is go ahead and try them on your own, or at least start it, squeeze some juice out of those givens, and then check with the video and see how you do. All right, great job on this, and I'll see you folks next time.